In this video, we are going to build linear regression model by using sklearn library. So in this video, we are using the data like Boston housing that we are predicting the price of the house by using the linear regression model. So we're building a model of predicting the price of the house. So let's get started the video. So the dataset is used about the Boston housing. It have the columns like crime, that means per capita crime rate by the town. Then certain the proportion of residential land zoned for lots over the 25,000 square feet. Then index the proportion of non-retail business acre per town. Then the Charles reverse dummy variable that is equal to 1 if the track bounds the rivers and 0 otherwise. Then the NOx means the nitric oxide concentration, the part of parts per 10 million. Then RM is average number of rooms per dwellings. Then age, the proportion of the owner occupied the unit by prior to 1940. It represents the age of the house. Then with the weighted distance of the 5 Boston employment center, the distance between the employment center and the place of residence. Then the RAD means index of accessibility to residual highways. Then the tax, the full value of the property tax rate per $10,000. Then the PTR ratio, PT ratio, that pupil teacher ratio by the town, it represents the education quality of the place. Then the LS stat, the percent lower status of the population. Then the mid value means median value of the owner occupied home in $1,000. So this is our the target variable by using these variables. These all are the independent variable from crime to LS stat or the independent variable. By using this independent variable, we are going to predict the mid value of the house. So by using sklearn, let's see how to build a model step by step, right from the importing necessary libraries to fitting the model. So doing all the pre-processing of data, then build a model using the sklearn. So first I will import all the necessary libraries for pre-processing of data. So I will import pandas first, pandas as pd, then I will import numpy as np. Then I want some visualization library like import seaborn. I will import seaborn for visualization, seaborn as sns. Then I will import the matplotlib pyplot as plot splt. So I will import these necessary libraries for the. So I have imported the libraries. Then I will read the data set. So my data set is the Boston house. So I will read like df is equal to pd dot read, that's in the cvs csv file. So I want the name of that. So I will use the name of that Boston. So let's see, where is that? Yeah, Boston cvs is file is here. So I will copy this name and I will paste it over here. So I will paste it over here. So name of the file is pasted. It will give the data frame to my data frame. If I check for my data frame, let's see. Yeah, this is my data frame. It have all the columns like I have already mentioned, like crime, zn index, just nearly 12 to 13 column. It has to. We're trying to predict this median value of the house by using all these independent factors. So let's see how to build it. So first, before we have to do some sanity checks. So first we will check the shape of the data. So to check the shape, df.shape, it will give the 506 and 13, means it have the 506 rows and 13 columns in my data. Then I will check the info of the data. So it will give oral information. So df.info. So df.info, it will give the overall information relating to all the columns, like it have the 506 entries, 0 to 505 indexes. It have total 13 columns. It have the columns name and the not null count. So here we can find that they don't have any null values. All the data types, it have the float and integer. We don't have any object data type, so no need to worry about the categorical column. So let's start doing some exploratory data analysis. So we start from df.describe. So we will do df.describe, then it will give the count, mean, standard deviation of each and every column like this. So if I want to transpose this, I have to use the point t. It will give this form. So here I can find that the mean of the crime rate and standard deviation and the certain index, all the information relating to the ranges of from here 46 percentage to 27 percentage. This is the range of this column. So this is how I can get some information about the data. So if I check for the after that exploratory data analysis, I need to do some visualization to understand the distribution of each column. So df of, so I will simply use df.hist to get the chart quickly. If I use this, it will give the histogram for the each column, like crime zn. So here I can get the histogram very small size. So if I want the big size, I have to use a for loop for that. So let's do it. So control, then the for loop. So let's see what will we get. So I will use the for loop for each element in df dot columns, means each columns I want to get dot kd plot. So data is my data frame. Then the x-axis I want to give each column. Then I want to show that all the chart plt dot show. So this might give some warnings. So I will first ignore the warnings by import. Sorry. So I will import warnings library, import warnings, then warnings dot filter warnings. within that ignore. So I will ignore all the warnings. So let's plot the chart. So we got an error because df.columns. Then the warnings, filter warnings, sorry, ignore. The G is missing. So yeah, now we got the KD plot for the each column. So this is how we can understand about the distribution. So here we can find the in crime, that is the right skewed. There is a skewness in the right side of the crime data. Then in Zn it's also right skewed. It has the multi-model data. Representatives have the two models, like two modes. Then we have the charts, like it's also right skewed, and we can understand about all the variables, all the columns one by one by looking at its distribution by using KD plot. So let's see our the mid value. It's also right skewed. So if we have the right skewness data for as a target variable, it won't give the best result. As when we check for the RMSE and we check for the residual, it won't give the best result. So for that purpose, we will do some transformation of the target variable. That we can do log transformation as well as the Cox transformation from sklearn. So I will show it in this video how to do the transformation of the data to get the best result. Before that, let's do some other missing value treatment. Let's find whether there is any missing value. So here we found that in the info there is no missing value. So let's check for the missing value, whether there is any missing value or not. So if I do some missing value, df dot is null dot sum, let's check for the missing value. Yeah, there is no missing value in my data frame, so it is free from the missing value, so no need to worry about that. So here I will do some visualization, like for the box plot visualization, to understand about the outliers, whether there is any outliers in my data. So I will change this to box plot. For each column I want box plot, so I want box plot the same. Yeah, I want to show the box plot for each column. So here I can find that in the crime and in the Zn, we also find the outliers in these columns by looking at these outliers. The box plot, we can find that in the room also we have the outliers, in the distance also we have the outliers. Like that we can find outliers in many columns. So let's do some outlier treatment. So before that I will show some the scatter plot before doing outlier treatment. So let's do the scatter plot also here. Control C, and I want to include another column. So here, then the Y is, I want to give the columns. So df dot columns, like I want only give the columns of independent variable. So I will paste it over here. Then it will give the all the columns. So I will remove this. I will remove this column. So first I will copy this and I will give it as a input for the for loop. So instead of df dot columns, I can give this. Then I will remove this because I don't want this target column here. I want the target column over as a Y. Then I will give the target column, that is my this column, Control C, and I will give it over here. Then I will plot a box plot for each column. So let's see. It got one error because I have some spaces over here. I need to remove that. Let's remove all the spaces. So we remove this and this space, then this space, then this. Let's remove all the spaces between the column name. So we removed, yeah, we removed almost all the. Then I have to put one colon over here. Yeah, now let's see what is the scatter plot for the each variable. Yeah, it's running. Yeah, we got a scatter plot for each and every. I need to change this to scatter plot here. Scatter plot. So let's see what will we get. Yeah, we got a scatter plot for each with combination of target variable, like here we can see some pattern, like negative slope. There is no pattern. Actually there is some pattern. There is no pattern. There is some negative slope. There is a positive relationship between the room and number of rooms and the median value. Then the age, like that we have the relationship. Let's see, this is before doing any outlier treatment. So let's do some outlier treatment for this data. Then let's get the scatter plot means relationship matrix for all. So for doing outlier treatment we need to create one. So outlier treatment we basically do by capping the value. So here the outlier, we cap the value till here, whether the any value above this upper whisker, we will cap it all the value to the upper whisker. So for that we will write one code, that is a function. So I will write one function, that is a definition, like I have to give the name of whisker. So this function will calculate the whisker of this. So whisker for each column. So I will give the input as columns. Then after that I want to calculate the q1 and q3 of the data. So I will use np dot percentile. So np dot percentile of this column, whatever I give it as input. Then I want to calculate the 25 percentile and the 75 percentile of the data. Then I want to calculate Then I want to calculate the IQR, means interquartile range. Interquartile range is Q3 minus Q1. So I got the interquartile range. After that I will find the low risker. So low risker is Q1 minus 1.5 into IQR. So 1.5 into IQR, it will give the low risker. After that upper whisker is equal to Q1 minus Q1 plus 1.5 into IQR. IQR. Then I want to return this, return low whisker and upper whisker. So this is the function. So let's run this. Then after that I will do the low whisker treatment, that outlier treatment, by imputing capping the value to the upper whisker and the lower whisker. For that I will use the for loop for that. So for each element in, so I have to get that column. So df dot columns. So remember one thing, we will do outlier treatment for only for the independent variable, means we don't do the outlier treatment for the target variable. In my case that is median value. So we don't do the outlier treatment for the median value. We do outlier treatment only for the independent variable, and it should be continuous numerical value. So we don't do the discrete value. So in my data set, all the columns, means all the data has the numerical continuous series. So I will do the outlier treatment for all the data except that the target variable. So I will use this. So then after that I will use the, first I will get the low whisker and upper whisker of each column by using that function that I have just created. So I will use whisker of df of I, that gives the column 2 as an input. Then I will use that df of I, means that column, is equal to, I will use np dot where to cap the value, np dot where to cap the value, where np dot where df of I, means that column data is lesser than, first lesser than low whisker. If the data is lesser than low whisker, cap it with the low whisker, otherwise keep the data as it is. Then for df of I, the df of I is equal to, if the df of I means np dot where is df of I is greater than the upper whisker. So upper whisker, cap it with the upper whisker, otherwise keep it as it is. So this will, here I will explain this code. So it will give each and every column as input. For this it will calculate the lower whisker and upper whisker of each column. Then it will go here and it will check the condition, like whether the df of I, means each element is, if that element, that value is lesser than lower whisker, it will cap it with the lower whisker, and if the value is greater than upper whisker, it will cap it with the upper whisker. If it is not, it will keep the value as it is. So this is how I can, and here I made one mistake. Instead of putting comma, I put the point. So I run this again. Then I will do outlier treatment by running this. So now the outlier treatment is done. If I now check for the box plot, so I will check the same box plot. So by copying the code, so I will just copy the code and I will check for the box plot. So let's see what will we get. So after outlier treatment, if I now check for the box plot, let's see. So now we can see we don't have any outliers in our dataset. So this is how I can do the outlier treatment. We can choose to do outlier treatment, or we can not choose to do outlier treatment. It's up to you. The ultimate goal is we should get the best predictive model. Based on, we need to check up whether the RMSE, R square, whether all that things, we need to get the best model. So we didn't get outlier treatment for the target variable, so there is outlier in the target variable. So I already told that we can do encoding of data. So in our case, we don't have any categorical feature, so no need to encode data. All the columns is in the form of numerical data, so no need to do that encoding of data. So here in the skewness of the data in the KD plot, we found that the target variable is right skewed. So we can do one thing, we can transform the data. So we can do log transform. So what will the transform do is, it will normalize the data. So if I have the target variable is right skewed, it don't show any normal distribution. So for best fit the model, to get the best result from the model, we need a normal distributed target variable. So we will do the transformation of the data before fitting the data into model. So we can do log transformation as well as the box-Cox transformation. I can do log transformation by using NumPy library. So if I want to do the log transformation, let's do by using np.log, just using np.log, and I give the input as that column. So that's my column is my target variable. So I want to transform this to normal distribution. So I will give this column. So let's see. So it will transform the data. That in the sense, it normalize the data. So it will change the data to normal distribution. So if I plot this, let's see, plt.sns.kd plot. So I will give the x is this. So let's see what will we get. So we got the KD plot like this. It's showing little bit normal distribution, not exact normal distribution, but the skewness is reduced compared to previous data. The skewness is reduced. So this is one way of transformation. Another way, we have many ways, but another best way is the box-Cox transformation from sklearn. So I can also do the box-Cox transformation of the target variable. So, and I can also do the box-Cox transformation to normalize the data. So from Scikit library, I have to import the box-Cox to transform the data. So I will import first from Scikit, means scientific Python, Scikit.stats import box-Cox. So if I use this and I imported box-Cox from the Sci-Fi, then I will use the df of that md mid, then this, sorry, I have to use the column name. So that is my target variable. So this is equal to, so I will do the boxcox. So I will use boxcox here. So boxcox of this column, I will do the boxcox transformation of this column. Then I have to give it in a double quote. So this will give the two output, that one the transform data as well as the LMD, means lambda. So I have to use these two variables to store that. Then let's do boxcox transformation. Yeah, our data is transformed now. So if I now check for the df, so this column, let's see what will we have. So let's check for the transform data. So this is my transform data. So it transforms the data like this. It will bring to the normal form. So if I now check for sns.kd float, that give x variable as this column. So let's see. Yeah, it's now normally distributed as we saw in the log transformation. This also normally distributed. So we can use any technique, whether it's the log transformation or the boxcox transformation, to reduce the skewness of the data. So this is how we can reduce the skewness. This is called as transformation of the data. After transformation, we can fit the model. So no need to encode the data. So our data is now free from the outliers and free from the missing value, and also the skewness is reduced on target variable. So now we can fit the model. So for building model, we need to import some library. So here we are building model using sklearn. So I will import from sklearn. I will import sklearn dot linear model, sklearn dot linear model, import linear regression. So this is the regression, linear regression. So by using this, yeah, I have imported, and I will initialize the regression. So I will initialize to model. So model is equal to that linear regression. So control C and control V. I will initialize to linear regression to model. So if I do that, after that I need to train and test the create x and y variable. After that I need to split the data. So for splitting the data, I need another module, that is train and split. So train, test, split. So I have to import from sklearn. So from sklearn import from sklearn dot model selection. Sorry, from sklearn dot model selection import train, test, split. So this will basically do the splitting of the data. So to check the data, or to check the model, we need train data and the test data to check the model's performance. So we will split the data into two parts, like training data and test data. And we will build a model on train data. After building the model, we will use the test data to test the model performance on the test data. So that's why we need to do train, test, split. So I will use this to train and test the data. So first I will create x and y variables. So I need to specify which is x variable. So x variable I want to choose only, means x variable means independent variable. So from the data, if I drop the MD mid, means median price, it will give the, so I will get the column over here, df of columns. So I want to drop this. If I drop this, let's see, control C, control V, I drop this from the axis, means the column. So before, let's see what will you get. So let's see. Sorry. Yeah, it will give all the column except that mid. This is my target variable. So I want target variable as a y. So I will get only the independent variable by this code, by using the df.drop. It will drop this column, except this, it will give all the data. So this will create it as x variable. Same way I create y variable. So y variable I want to include df of that target variable, that is median value, median price. So this is how I can define the x and y variable. After that, after creating x and y variable, I need to split the x and y into train and test. So I will use x train, comma, x test, comma, y train, comma, y test. So it will, the train test split give the 4 output, that is x train, x test, y train, y test. So after that I will use this train test split. Okay, train test split here is equal to train test split. Within that I will give the x that I just created, x and y through split, and I have to mention the test size, means size of the test. I will give 0.3, means 30% of this data is created as a test. It will split the data. If I have 100% data like this, to the 100%, it will split the 30% as a test data. So after that I have to give the random state random state is equal to 42, because is make sure that every time I split the data before, after building model, it will choose the same column, same split, it will do the same split. So I have to use the random state is equal to 42. Then if I run this, sorry, test size is equal to 30%. So it has converted that my data into train and test. After that, we need to fit the model. So we have the model regression, linear regression is a fit that stored in model. So I have to use model dot fit x train and y train. If I use this x train and y train, it will fit the model in. To validate the model, I need to get the R square. To R square, I need to first predict the data. So let's predict the data first before getting the R square. So for predict, I just need to use that. I will store it in y predict. Whatever the result it gives, the predicted value. So y predict the model dot predict. If I use model dot predict that x test. If I use x test, it will predict. So if I now check for the y predict, so y predict, it will predict the data. So yeah, it's my predicted data. So for getting R square, I need to import from in sklearn. I need to import from sklearn sorry, from sklearn dot matrix. So from sklearn dot matrix, I have to use mean squared error, and I have to import R2 square means R square score. So R2 score. So I will import this too. Then the mean squared error matrix import. Okay, import mean squared error and R2 square. After that, I will get the R2 square, like R2 square, R2 score of y test and y predict. I already predicted the value. So y predict, if I give this, it will give the R square. Means the R square of the model is 74. It's above 62%. So it is on the major side. So its model is fitted in terms of R2 square. So if I want to get the RMSE, so let's before that check for the coefficient of the model. So coefficient of the model is model dot coef underscore. It will give the coefficient of the all the columns. So it will give the coefficient of the all the columns. So I will store it in a coef. So that is stored in a coefficient. So after that, for I have to show it with each column. So for I in zip, so I'll use zip file to combine that. So I zip of that the column means x train dot columns and that coef, and I want to show like I comma j, because I have two. So I comma j, I want to show it like the I within this. I will print that the print and format the I and equal to, and again format that j. I want to show the coefficient like this. So let's see what will we get. So here I need to give only one. So let's see. Yeah, it will give the coefficient of each and every column. Like for crime, it have 9% coefficient. For ZN, it have 0.3% indus, like that. It will give the coefficient of each and every. So by this, we can interpret which variable has the major coefficient. So after that, we need to calculate the RMSE of the model. So for RMSE, we have already imported from sklearn the mean squared error. So the means, I will use that mean squared error. Mean squared error, I have to use y test and y predict. It will give the mean squared error. So this is my mean squared error. If I square this, if I get the square root of this, it will give RMSE np dot sqrt. If I get the square root of this, it will give the RMSE of the model. So the RMSE is 34%. So in order to validate the RMSE, it should be 10% of the maximum error. So maximum error means y tests. If I get the mean of the y test, it will give maximum error, that is 4. If I get the percentage of that, so I have to get the percentage of this, like the RMSE divided by the maximum possible error, it should be within the 10%. If it is more than 10%, yeah, it is within the 10% of this. So we can say that the model is validated in terms of RMSE also. So to do the residual validation, we have to get the residual. So we already have the, we don't have the residual, we need to get the residual. The residual is get by the y-test minus y-predict. If I get y-test minus y-predict, it will give the residual of this. So I will store it in the residual. So residual is equal to y-test minus y-predict. So residual is stored now. Then if I do the validation of residual, so for the validation of residual, we need to fulfill three conditions, like the mean of the residual should be 0. So if I first check for the residuals dot mean, it should be 0. So sorry, residual, it should be 0. So it's a negative, yeah, it's nearly 0. So we can say that it's 0. Then second condition is, one condition is met. About residual, the one condition is met. Then if I check for the second condition, that is the skewness of the residual should be normal. The residual should be normally distributed. For the distribution, I need to get the KD plot, means sns.kd plot, sns.kd plot x is equal to residual. So let's get the KD plot of this. So let's get the KD plot of the residual. So we can say it's slightly normally distributed, but we have the many skewness in the target variable, it's a little bit skewed now. So if I get the skew score of the residual here, the residual dot the skew, if I get the residual dot skew score, it will give the 0.71. So it's above 50%. So it's slightly right skewed. So the condition not met exactly. We need to do some work on to bring that to normal distribution, not met. So this is not met. Then the third condition is that it should constant variation between the predicted value and the residual. So for that, I will use scatter plot, sns dot scatter plot, sns dot scatter plot. The x is my y test. So I will use y test as my x, and the y is my residual. So let's see whether there is any relationship between that. It's slightly showing the positive relationship, so the condition not met. So for the condition of the best fit model is the R square should be more than 62% and less than 90%. If that is more than 90%, the model, we call it as the overfitted. Then the second, about RMSE, the RMSE of the model, it should be within the 10% of the maximum possible error. Then about the residual, it should have the mean of the residual should be 0. That is met. Then there should be no relationship between the constant, that y test and y residual, but here we showing some relationship, so that is not met. Then the residual should be normally distributed. So these condition met, we can call it as the best model. So this is how we can build a model using sklearn. So in this video, we learned from the beginning, from doing some pre-processing of the data, like importing necessary libraries, reading the data. After that, we did sanity check of the data in order to understand about the outliers, missing value, all those things. And we did exploratory data analysis to understand about the distribution and the skewness and the outlier and the relationship between the data. Then we did missing value treatment. Then we did outlier treatment by Whisker. Then after that, we also did some transformation of the data to reduce the skewness. Then after that, we build a regression model by using sklearn. After fitting the model, after importing some libraries like import from sklearn linear model, import linear regression, then we train and split the data. After that, we fit the model in x-train and y-train. After that, we predicted y-predict. After that, we got R square from the import, mean square error and R square score. From this, we got the R square of the model, that is 74%. After that, we get the coefficient of the model, that is for all columns. Then after that, we get the mean square error and RMSE of the model, that is 74. And after that, we check for the RMSE within the 10% or not, that is validated. After that, we check for the residual condition, that's the whether there is a normal distributed, the mean of the residual is 0 or not, whether there is a relationship between the predicted value and the residual. So this is how we can build a model. But the disadvantages of this sklearn linear regression is we don't find any p-value. So while building the model, we will look for the p-value, and if the p-value is more than 5%, we used to remove that column and again build the model. So but the sklearn model don't show any p-value matrix. So for getting the p-value, we use stats model. That's another library. By that also we can build the regression model. So in the next video, we will see about how to build the regression model using the stats model library. So this is about this video. Thank you for watching. Stay tuned, stay learning. Thank you.